guys, back at again with another video. So today we're going to do a two object system connected by a pulley but with friction. So the first thing we're going to do, we're going to draw out both of our boxes after really diving into the question. So two boxes connected by a weightless cord, which is good. We don't need to take account of the weight of the cord. Running over a frictionless pulley, also good because you don't have to take account of the friction of the pulley. And then box A has a mass of 9 kilograms. It's initially at rest on top of the table. The coefficient of static friction between box A and the table is 0.5. 0.15. Box B has a mass of 14 kilograms, and the system begins to move just after it is released. And it wants us to calculate the acceleration of the blocks and the tension of the cord. Okay, so first we need to draw out all the forces acting on each block. So for block A, we have the normal force, since it is sitting on a table. We have its force of friction, pulling in the opposite way of the acceleration. Force tension, which is caused by the cord. And then we have the force of gravity A, which will be ma times gravity. But actually, since the blocks share the same cord, they're going to have the same force tension, so they'll have that in common. The block B, or the blue block, it is going to have the force tension from upwards. Because it is hanging off the side of the table. And then it's going to have its force gravity downwards. So mb gravity here. It doesn't have any force normal because it is not currently sitting on anything. It's just hanging from the cord. And it's also not going to have a force of friction since there's nothing it is sliding against that's going to cause it to not be as fast in its acceleration. So if we look at the acceleration of both blocks, A is going to the right in this case. And then the block B the acceleration is going downward since block B is heavier and the entire system is going to move this way. So now that we have all that cleared up, we can start looking at it from a more mathematical standpoint or view, I guess. If we start with block A, or box A, I keep calling them blocks, but I think they refer to them as boxes. We find that the sum of forces on the x-axis are equal to, first we're going to do the force tension. Because the force tension is positive, is going in the same direction as the acceleration. The only thing on the x-axis that is opposing our acceleration for block A is our force of friction. So, and then if we really take a look at this, we know that the sum of forces is always equal to mass times acceleration at constant acceleration. So we can rewrite our equation like this. Another thing that we know is that force tension is going to be equal between block A and block B since they are sharing a cord, and the tension of the cord is going to be the same for each of them. But the force of friction for block A is always equal to force normal times the coefficient of kinetic friction. And since the force normal is opposing directly its force gravity, it's going to be equal to the same thing. So if we rewrite this, we can say mass times acceleration equal to force tension minus mass A gravity, which is force normal in this case, times mu k, which is our coefficient of static friction. Mentioned that it's 0.15 inside of the question up here. So now if we rearrange for it to equal tension, we have that force tension is equal to mass A, acceleration, plus mass A times gravity and mu k. Now if you take a look at block B, or box B, we have only on the y-axis here, so sum of forces y is equal to mass times acceleration. Since we are exhibiting some acceleration, it's not equal to 0 because we are in movement, because it's just after the blocks are released. We're trying to find the acceleration at that point. So the sum of forces, here, we'll go back a little. The sum of forces on the y-axis, what is going with the acceleration will be positive, so mass B times gravity is going with acceleration, and the force of tension is opposing it. So we know it equals ma is equal mbg minus force tension, and if we want to solve for tension, we have force tension equals mbg minus mba. So in this case, we have two equations. We have one over here, second one over here, but we know they share the same tension. So force tension is equal to force tension, or equation 1 is going to be equal to equation 2, basically. So if we rewrite this all together, we have ma acceleration plus ma gravity mu k is equal to mb gravity minus mb acceleration. So we know our mass for A. Our mass for A is 9. So 9 acceleration plus 9 times 9.8 for gravity times 0.15 for our coefficient is equal to mass B, which is 14, times 9.8 for gravity minus 14 times acceleration. Put it all together and we get that 23 acceleration is equal to 123.97. And if we divide each side by 23 over here, get the acceleration is equal 5.39 meters per second. So that's all dandy, but we still need to find the force of tension. We can use either of our previously made equations over here. I'd rather do number 2 because it's just a little bit simpler. So if you do equation number 2, we have that force tension equals mass B gravity minus mass B acceleration. And now we have our acceleration to complete this. Force tension is equal to, I believe it was 14 times 9.8 minus 14 times 5.39 meters per second squared. Sorry, proper units. So now that we have that, it's equal to 61.74 newtons. Beautiful, dandy, but it kind of was a long process to get here. So I'm going to show you guys a bit of an easier method to complete this question. I don't know about you, but when I did physics, it was mostly multiple choice questions, and it would have been a lot easier to do this method on a test, especially when these tests were timed, and then I could have had more time to complete the other questions. But I will just show you this little trick, since it'll make your life a little easier. So here's a copy of our original system. So this method, what we're basically doing, we're looking at the system altogether instead of dividing the forces on the blocks. But we still need to look at all the forces on the block. So if we just make a little diagram of everything, here we'll use the same color. So we have force tension here, force tension here. We have mass B gravity here, mass B gravity here, or sorry, not B, A. Mass A gravity here, force normal of A, and then right here, force friction A. So those are all of our forces if we just put it together in our original diagram. So what we can do, we're looking at the system altogether. So our force of tension on A and B are the same, so those can just cross out. And also, our force normal A and our force of gravity A are equal to each other, so we don't need to worry about those either. So what we're doing for this method is basically finding the forces that are in the same direction as the acceleration, and then taking away, minus, the forces that are opposing the acceleration. And since we're doing this inside of our system, we're taking it as the entire system instead of just the two blocks. We have to divide it by both of the masses. So mass A plus mass B. And this is going to give us our acceleration. So it'll make a little more sense in a second. So what forces are with the accelerations that are even left? Let's take away the forces we don't even need. We don't need this one. That one's gone. That one's gone. So we only have two forces left that we're even going to consider. One here, one here. Force, the gravitational force of B, this is in the same direction as the acceleration overall. So it'll be positive in this case. So MBG is positive. And then our other force we're considering is over here. And it is opposing our acceleration. So it is negative in this case. So it's minus the force of friction of A. And this is all on MA plus MB. And like previously discussed, we already determined what force of friction A is, and that it's MAG mu K. So we already have that established, which it normally is MAGUK unless it's on a slant or there's something making the problem a little bit more difficult. So acceleration is equal to mass B, 14 times 9.8, minus mass A, which is 9 times 9.8 times 0.15, all on the masses together, which is 14 plus 9. If we solve for this, we will find that the acceleration is 5.39 meters per second squared, just like inside of our first method. So that all checks out together. And if we wanted to solve the second problem with this method, this method is a little more visual. So if you have a lot of experience with these questions, it should be pretty simple to grasp. But if you need the first method, don't be afraid to use it. It's a little bit longer, but it guarantees you will have the right answer at the end. So if we wanted to find the tension with this method, since we don't know all of these equations, what I normally do, I will use the block B as a reference to find the tension, since there's only two forces acting on it. We only have force tension at the top, and then we have MBG at the bottom. And then we know the acceleration is downwards because the acceleration, or the mass B, is heavier, and we'll have the block going downwards. Sorry, I can't find the words for this right now. Well, anyways, so we know there's only two of them. So we know that the sum of forces Y is going to be equal MBG positive, so that's going with the acceleration, minus force tension. We know we're in movement, so it's going to be MA equals MB, which BA obviously, G minus FT. And then we can rearrange this pretty simply to just be MB and then G minus A, just to make it a little more simpler. Force tension is equal, B was 14, 9.8 minus 5.39. And overall, this equals 61.74 newtons for our tension, which is the same in the first question as well. So yeah, this is the end of our video. Don't forget to like, subscribe, and share. I also recently made a Google Forms that you can ask me some questions in, and I'll be happy to answer any of your questions. I'll make a YouTube video explaining them all. There's also a little section you can add in pictures, because I know some of these are physics questions and kind of hard to explain just with words. But yeah, that's the end of my video. Thank you so much for watching.